All right, the last thing we're going to start to finish up here is discussing real numbers and their positions. All numbers that can be represented on a number line are called real numbers and can be classified according to their characteristics. Okay, so what we're going to distinguish is we're going to have real numbers, and inside the real numbers you can see that we can give a lot of names to certain things like 2. But we also have irrational numbers, okay, which don't have any of those subgroups. So breaking down each of those subgroups, and I'll come back to this picture here in just a little bit, what I have is I have the natural numbers. The natural numbers are numbers you first started learning to count with, like 1, 2, 3, 4, 5. You can notice that those are the purple group inside here and have an abbreviation of N. The second set is the whole numbers. There's one number difference between the natural numbers and the whole numbers, and that number is 0. So that's the only thing different between natural numbers and whole numbers. Notice that the whole numbers are one outside of that group and they only have the number 0, but whole numbers also include all the natural numbers. So it's 0 and all the natural numbers, and the abbreviation for that is W. The next subgroup is integers. Integers are the whole numbers and their opposites. So 3 and negative 3, 2 and negative 2, 1 and negative 1. So integers, we don't use the initial I because we use that for irrational numbers, so we use Z as the abbreviation. Notice that it includes 1, 2, and 3, and its opposites, as well as 0. The last subgroup there is the rational numbers, and rational numbers can be expressed in a fraction form. Okay, those fractions could be repeating decimals or terminating decimals, meaning they end. So all of these things are rational numbers: repeating decimals, fractions, terminating decimals, decimals that end, fractions. Okay, this is what I just discussed with rational numbers: terminating decimals. A decimal that ends has a finite number of digits. Repeating decimals means that this would be 1.33333 or 0.66666. We've got numbers that are being repeated. The last part we need to talk about is irrational numbers. Irrational numbers cannot be written in a fraction form. They include the square roots of whole numbers that we don't know, so those non-perfect square roots, and also numbers that we know that do not repeat. Pi is one of them, and so is E. E is 2.71 something something. It's like pi. So all of these are irrationals. So a number is either rational with an abbreviation of Q or irrational with an abbreviation of I. Every number is a real number. Inside the rational numbers, you might have an integer, a whole number, or a natural number. We're going to start to just put classifications with each of these numbers, and that's the last thing we're going to be doing in this section. So I have 5 numbers here, and we're going to write all the classifications that apply. What I'm going to do is I'm going to start with the innermost, or the outermost number, and they're all real numbers. So I'm going to go ahead and put it's a real number. Then I'm going to work my way inside. Is it rational or irrational? In this case, this is a rational number because it doesn't go, it can be written as a fraction, 32/1, whatever the case might be. I'll use Q for rational, and I'll write that above on this one. I'm not going to do this in all of them. And then the next subgroup is integers. Integers are negative numbers or positive numbers. This is a negative number, so it is an integer. The next subgroup is a whole number. Well, it's not a whole number because it's not 0. So these are the 3 classifications that apply to that number. The next one is a real number. It's rational. It's an integer. It is a whole number, and it is a natural number. The reason why it's a whole number, even though it's not 0, is because whole numbers are 0 plus all the natural numbers. And since it's a natural number, it becomes a whole number as well. So it happens to be all 5 subgroups. The next one is a real number, and it's rational because it can be expressed as a fraction. It is not an integer because it has a fraction form. Integers look like this part right here where they don't have a fraction or a decimal. The next number is a real number. It is a rational number. It can be written as a fraction, and it is an integer because it's a negative number. It is not a whole number because it's 0 in the natural numbers. This is not a natural number. The last part is an irrational number. So it's only it's a real number and a rational. So it's real and irrational. There are no subgroups once you say it's irrational. It's just simply irrational. Again, bring all your questions to class and we'll discuss these further.